So the transition from Euclidean space with dot product to a vector space with inner product. Remember that when you have Euclidean space R to the n and a dot product, you can take any vector and you can define the magnitude of that vector using square root of v1 squared plus v2 squared plus vn squared, which is basically the square root of the dot product between v and v. But in general, if you have a vector space like v and you have the inner product as a function defined on it, you can take any vector like v in that vector space and you can define the magnitude or norm of that vector using this new function v and v, the inner product between v and v. So basically you can write it this way. The length to the second power is equal to the inner product between v and v. Remember, we talked about distance function as well. We said the distance is defined this way. So this is for the length. If you have u, which is, for example, u1 to un, and you have v, which is v1 to vn, you can define the distance between them. The distance between u and v is equal to the magnitude of the difference between these two. All right. So it was basically the square root of u1 minus v1 squared plus un minus vn squared. But now that we transitioned to a new function, the inner product, we're going to change all of these. Now, if I ask you to find the distance using the inner product, we're going to define and write it this way. V along with the inner product, the distance between u and v is basically the magnitude or norm of u and v difference. So this is basically equals to, if I ask you to write it in this format, you're going to say that, hey, this is the square root of the dot product between u minus v and u minus v. Or basically, if I square it, the distance squared is equal to the inner product between u minus v and itself. Now let us take a look at this example. All we said was to apply this somewhere, somehow, which you saw before. For example, consider v to be the vector space of all continuous functions between a and b. We're going to define the inner product between two continuous functions as the definite integral of their multiplication. This is indeed an inner product. You can check. It's basic algebra. Now, suppose I give you f of x to be x and g of x to be a quadratic function, and I'm going to define it on 0 to 1, the closed interval 0 to 1. I ask you to find the magnitude or norm of function f. What is this? So remember that for any vector space that has an inner product, the definition of the magnitude or length is related to the inner product. So basically, I can say that, hey, the magnitude to the second is equal to the inner product between f and f, which is the integral 0 to 1 x times x dx. This gives me 0 to 1 x squared dx, which is a third x cubed between 0 to 1, or the magnitude to the second power is 1 over 3. If I take square root of both sides, the magnitude or length or norm of f is 1 over square root of 3, or square root of 3 divided by 3. Now, suppose I ask you to find the distance between these two functions. I ask you, what is the distance between f and g? What are you going to do? You're going to say that, hey, distance has a definition. It is the square root of the inner product between f minus g and itself. Or basically, if I square this guy, makes it easier to do the computation. You have the inner product between f minus g and f minus g. Very good. This guy is equal to, based on the definition, integral 0 to 1 f minus g multiplied by f minus g. X minus x squared times x minus x squared dx. This is easy for you. You saw this in elementary calculus. You get integral 0 to 1. You can do the distribution. You get x squared minus x cubed minus x cubed, negative 2x cubed, and plus x to the 4th dx, which is basically x cubed divided by 3 minus 2/4 x to the 4th plus 1/5 x to the 5th, 0 to 1. Once you do the algebra, this guy is equal to 1 over 30. So the distance between f and g is equal to 1 over square root of 30, or square root of 30 divided by 30, or you can simplify it as much as you want.